So another calculation with moles, this time looking at going from atoms of an element to the mass of a compound. So as we always do, we want to start by reading our problem. A sample of sodium chloride, NaCl, contains 3.42 times 10 to the 23rd atoms of chlorine. What is the mass of the sample? So we're looking for mass. It doesn't specify, so we're going to report it in units of grams. So we're given a number to start with, so we'll start by writing that down. Now again, I don't know any relationship between atoms of an element and grams of a compound. So what I'm going to do is I'm actually going to convert to moles. And so I know that I have 6.022 times 10 to the 23rd atoms in 1 mole of chlorine. Now I need to figure out how many moles of chlorine it's going to take to get 2 moles of my compound. So in this case, I know that for every 1 mole of chlorine, I have 1 mole of sodium chloride. It's kind of like saying if I have a dozen bikes, I have a dozen bike frames as a part of those bikes. Now sometimes it's going to be a 1-to-1 ratio, sometimes it's not. So you always want to make sure you check that and you always write it in, even if it's a 1-to-1 ratio, just so that your units cancel out correctly. Now we look at our moles of sodium chloride and we want to get 2 grams of sodium chloride. So we can look at the molar mass, which is 58.5 grams per mole of NaCl. Now I can go back and look at my units and I see that atoms cancel with atoms, moles of chlorine cancel with moles of chlorine, moles of sodium chloride cancel with moles of sodium chloride, and I'm left with units of grams. Had I left this step out, I would have had moles of chlorine in the numerator and moles of sodium chloride in the denominator, and I cannot cancel those out. Even though they're both moles, they have to be the moles of the same substance. So always put this mole ratio in here to make sure you're getting your units to work out correctly. Now I can go to the calculator. I'm going to start with everything on top. So I have 3.42 times 10 to the 23rd times 58.5 divided by 6.022 times 10 to the 23rd. Again, making sure that you use the scientific notation correctly, especially when you're dividing, so that you get to the right answer. And what we find is that we have 33.2 grams of NaCl. And I need my 3 sig figs because my number going into the problem here had 3 sig figs. Now for molar mass, I had 3 sig figs there. Had I had a value that had 4 sig figs to start the problem, I want to make sure that my molar mass has as many or more significant figures in there. I don't want that to be a limiting factor in determining the precision of my answer. So we get 33.2 grams of sodium chloride.